Okay, looking at the entire expression and noting what the derivative of this expression is, and actually let's write out just one more step for this expression. This is going to be second derivative of theta with respect to t times u sub theta plus u sub theta prime, that's going to be d theta dt times negative u sub r d theta dt. Since we have the d theta dt twice, let's write this out as second derivative of theta with respect to t times u sub theta plus, well, it should have been minus, we'll put the minus in here and take care of that later, ur times d theta dt quantity squared. D theta dt times d theta dt is the square of d theta dt. Note that's not the same as the second derivative of theta with respect to t. So our expression for r double prime of t becomes what? R prime prime is just r double prime, and that's times u sub r. Now u sub r prime is u sub theta times d theta dt. So we have then r prime multiplied by u sub theta d theta dt. And we have this term, which is okay as it is. Don't think I have room to squeeze that in here, but I'm not going to let that prevent me from trying. Okay, so that's going to be, write my letters a little bit narrow, r prime d theta dt u sub theta. Okay, these three terms are just fine. This term comes out to be equal to this. Well, actually, this derivative comes out to be equal to this. We still have the r to distribute through this expression. And what we end up with then is r times the first term of this expression, which is second derivative of theta with respect to t times u sub theta, minus, because of the negative u sub r times d theta dt quantity squared times u sub r. Now finally, we just want to collect our u sub r and u sub theta terms. So I'm just going to go through the expression and pull out anything that's a multiple of u sub r, and that's going to be r double prime from here, no u sub r here or here, but there's a u sub r down here. So we have negative r times d theta dt quantity squared multiplied by u sub r. Now, pulling out our factors of u sub theta, we have what? R prime times d theta dt, and notice that here we also have an r prime d theta dt multiplied by u theta. That gives us 2 r prime d theta dt, and then we have a u theta term here, which is just r times the second derivative of theta with respect to t, and that's times our u sub theta vector. Now we've got an expression for a general expression for the second derivative of any position function, where the position function is r of t equal scalar r of t multiplied by u sub r.